Okay, so we have three mixtures. First having water and liquid A in whatever ratio. Second having water and liquid B some ratio, and water and liquid C in another ratio. Now we are mixing the three things, the mixtures of these in the proportion. So this is something I've explained in one question of this slot itself. So this is the type I was talking about. If you have a type like this, then you don't need to apply alligation. There is a much faster method. So I'll explain that here. So first of all, let me note this down. So we have three things here: water, A, B, and C, and we have three mixtures. So the first mixture, water and A, are in the ratio 1:2. So there is nothing of B and C in it. The second one has water and B in the ratio 1:3, and the third one has water and C in the ratio 1:4. So this is what we have, the three mixtures, right? So these are the three mixtures that we have. Yes, the three mixtures are mixed in a certain ratio that is mentioned here. But before getting into that, let's figure out the total according to these numbers itself. So in the first mixture, we have a total of three, one and two. In the second mixture, we have a total of four. And the third mixture, we have a total of five. Always in these questions, if you want to solve this quickly, try to first get this ratio or these numbers to the same number. So what you do is just take the LCM of this. So 3, 4, and 5, the LCM is 60, right? So try to understand what needs to be multiplied. So I'll always put a bar to understand whatever I'm multiplying. So whatever I have to multiply to each of the numbers to get it to 60. So first let's get everything to 60. So I'll multiply this to 20, I'll multiply this to 15, and I'll multiply this to 12. Now, as soon as I've done this, what happens is I have got everything in the ratio 1:1:1. Now, from 1:1:1, I can achieve any ratio very quickly. That is simply by multiplying the parts. So I need the ratio as 4:3:2. So the next thing I have to do is I have to multiply a 4 here, a 3 here, and a 2 here. Just rechecking whether this is correspondingly or not. So A, B, C, yeah, that is corresponding. So don't make a mistake. Check it before. I forgot to check this before. So just let me write this 4 properly. I hope that is legible. So 4:3:2, right? So now the reason I put this bar is, so now I know whatever has to be multiplied to the first ratio, whatever has to be multiplied to the second ratio, and whatever has to be multiplied to the third ratio. Because whatever I have to multiply, I have to multiply to the parts also, the individual parts. So now check this out. So in the first ratio, we multiply 80. Now water is in each of the parts, right? So we'll evaluate the water thing later on. So I'm just going to put some additional lines here just to discriminate between A, B, C and the water. So just multiply 80 to the 2 first of all. So 2 into 80 is 160. This is done. 3 into 45. So that is 135. This is also done. 4 into 24. So that is 96. So this is also done, right? So now as soon as you get this, now get the water. Yes, the water are in each of the parts, but then the advantage is each of these parts are one part only. So all you have to do is just add these numbers, because 1 into 80 will be 80, 1 into 45 will be 45, and so on, right? So simply add these factors. So 80, 45, and 24. So you have 80, 45, and 24. If you quickly add this, these two adds up to 104. So that you have 149, right? So 149 parts. So now you get this as the combined ratio of water A, B, and C. So as soon as you get these numbers, now whatever is required, you can figure out, right? So the basically in this question, you're looking for resulting mixture has one of these options will be correct. So let's check this out. Same amount you can ignore because nothing has same amount, right? You can check all these numbers. So A and B are straight away out. C says more water than liquid B. That is incorrect. What? No, that is correct actually. Sorry. So water is actually more than B, right? So that is the correct answer. D says more water than liquid A. That is incorrect. I actually read this as liquid A, but C is correct. More water than liquid B, but not more water than liquid A, right? So option C is the correct one here. I've already marked it. So just let me take these circles off. Yeah. So coming back to this option C. So option C said more water than liquid B. So that is advantage. You can just simply deal with these numbers. So 149 and 135, but not water than liquid A, right? 149, 160 is more. So option C is correct here. So I hope that was understood. So this is very, very fast process. You can apply this method in a lot of these kind of mixing problems. Just play with the numbers. There's nothing to it. It's after all ratio. You can just keep all the relationship holding true, and then automatically everything adjusts for itself. So the main challenge is to make the relationships holding true, and that is the reason why this step is the very important one. Sometimes you might get comfortable ratios here. For example, if this ratio would have been 6 is to 4 is to 5 instead of 4 is to 3 is to 2, I can find that originally with the parts I have 3 is to 4 is to 5. In order to make it 6 is to 4 is to 5, all I have to do is multiply the first one with 2, and that's it. The rest will automatically adjust, right? So but in most of the cases you have to get it to first 1 is to 1 is to 1, and then whatever parts you have correspondingly, just multiply those numbers. So this is a fast method, but then this would take a bit of time to actually do it correctly. So I would say 1.5 minutes is an ideal time to solve a question like this. It might go to 2 minutes. I won't say that solving this in 2 minutes would be a bad thing. But then ideally, you should solve it in 1.5 minutes. So this is what I feel is the ideal time to solve this question. So that's it for this question. I hope you understood this process and you'll apply them in your actual questions. Thank you.